Section 1. The first two letters. A digital Big Bang. It all started with a simple, incomplete word. On October 29, 1969, a young student programmer named Charlie Klein sat in front of a teletype machine at UCLA. He was about to send the very first message over a brand new computer network. The plan was to type the word login to connect to a computer hundreds of miles away at the Stanford Research Institute. He typed the L and asked his professor, Leonard Kleinrock, if the team at Stanford received it. They had. Then he typed the O. The system promptly crashed. The first message ever sent across what would become the internet was just LO. LO were not a failure, but a profound beginning. They were the first digital whisper across a vast distance, a proof of concept that a new form of communication was possible. Before this moment, computers were mostly isolated giants, processing data in their own rooms. The idea of linking them together to share resources and information was revolutionary. That brief two-letter transmission was the spark. It demonstrated that machines could talk to each other over a network, setting the stage for everything that would follow. The network itself was a government-funded experiment called ARPANET. Its goal was to create a decentralized communication system, one that could withstand damage in one area without collapsing entirely. This was a direct response to Cold War fears. The architects imagined a web where information could be routed around obstacles, ensuring that communication lines would remain open even if parts of the network were destroyed. This core principle of resilience became a foundational element of the Internet's design, allowing it to grow organically and robustly over the decades. It was a network built for survival. The LO message was a small, almost comical step, but it represented a giant leap in human connectivity. Think of it as the digital equivalent of the first footprint on the moon, which had happened just a few months earlier. While one event explored outer space, the other explored an entirely new kind of inner space, a virtual realm built from data and code. That partial word, transmitted from one room to another, was the first sign of a new world being born, a world where distance would no longer be a primary barrier to sharing knowledge and ideas. Section 2. How the first network worked. The magic behind ARPANET was a groundbreaking concept called packet switching. This was the clever idea that made the network so resilient and efficient. Instead of sending a long, continuous stream of data like a phone call, packet switching breaks a message down into small, neatly labeled pieces called packets. Each packet contains a small part of the message, along with the address of its final destination and its sequence number. These packets are then sent out into the network independently, like letters mailed in separate envelopes. They don't all have to take the same route to get where they are going. This method offered incredible advantages over traditional circuit switch networks. If one path on the network was busy or broken, a packet could simply be rerouted along a different path. This made the entire system incredibly robust. The packets would travel through various nodes, the connected computers on the network, and find the most efficient way to their destination. Once all the packets arrived, the receiving computer would use their sequence numbers to reassemble them in the correct order, recreating the original message. It was a distributed, flexible, and self-healing way to send information across great distances. The original ARPANET had just 4 of these nodes, and the team at Stanford, where programmer Bill Duval was waiting to receive the message. The other 2 initial nodes were at the University of California, Santa Barbara, and the University of Utah. These 4 locations formed the tiny backbone of the nascent Internet. Charlie Klein's attempt to log in was the first test of this 4-node system. Even though the system crashed after just 2 letters, the successful transmission of those packets proved that the fundamental idea worked. The LO was a monumental success because it confirmed that packet switching was viable. The system didn't fail because the idea was wrong. It failed because the software on the receiving computer wasn't ready for the incoming data. The packets themselves, L and O, had made their journey successfully. This confirmation gave researchers the confidence to keep building, improving, and expanding the network. That small test laid the groundwork for a system that could grow indefinitely, one packet at a time, eventually connecting not just 4 computers, but billions. Section 3. Billions of connections. Today's internet. From those first two letters, the internet has grown into a global phenomenon of unimaginable scale. The initial 4 nodes of ARPANET have multiplied exponentially. Today, it is nearly impossible to give an exact count. The number grows every second. A conservative, widely used estimate, around 30 billion connected devices. Staggering, nearly 4 times the entire human population. These devices are no longer just large computers in university labs. The devices now online encompass almost every aspect of modern life. Smartphones, laptops, smartwatches. But the network extends far beyond personal gadgets. Smart televisions, home security cameras. Digital assistants like Alexa and Google Home smart refrigerators. This is the Internet of Things, everyday items given a digital voice and the ability to communicate. This explosion of connectivity has reshaped society. Work, learn, shop, socialize information, once locked in libraries or available only to specialists, is now available to anyone with an internet connection. Collaborate in real-time, access a global marketplace from our living rooms. The internet is the central nervous system of our global civilization, a utility as essential as electricity or running water. Think back to the single UCLA-Stanford connection. The contrast is immense. One fragile link, a dense, overlapping mesh of billions of connections, satellites orbiting Earth, undersea fiber optic cables. Every time you send a text, stream a movie, or check the weather on your phone, you send packets through this colossal network. What began as a military experiment has become an indispensable public square, a vital economic engine, all built on packet switching, that first LO. Section 4, the age of AI, a smarter network. Today, the internet is undergoing another profound transformation, driven by artificial intelligence, or AI. AI gives machines the ability to learn from data and make intelligent decisions without explicit programming. On the internet, AI acts like a sophisticated brain, analyzing massive flows of information to make services faster, more personal, and more efficient. Netflix recommendation engine, suggesting movies based on your viewing history. Email spam filtering. AI makes the internet more intuitive and predictive. For example, Google Maps. For example, Waze. AI constantly analyzes real-time traffic data from thousands of users to find you the fastest route. It anticipates traffic jams before they become severe and reroutes you accordingly. Online shopping sites use AI to show you products you might like, learning from your clicks, learning from your past purchases. AI is a pattern-finding machine, sifting through mountains of data to find meaningful connections and predictions. This integration of AI is not just about convenience. It is making new things possible, helping doctors in remote areas diagnose diseases with greater accuracy. In education, AI can create personalized learning paths for students, adapting to their individual pace and style. AI-powered systems help manage the complex flow of data across the internet itself, optimizing network traffic to prevent bottlenecks and ensuring video calls and streaming services run smoothly. It is a tool that is making the network itself smarter. The journey from LO to an AI-powered global network is a testament to the power of incremental innovation. That first, simple message was a starting point, a question waiting for an answer. Today, AI helps us answer ever more complex questions using the vast web of connections that grew from that initial experiment. The future of the internet will be shaped by how we integrate this intelligence. Build a network that's smarter and more efficient, more equitable, secure, and beneficial for all of humanity. The story that began with LO is far from over. It is just getting more intelligent.